Okay, a bag contains the following candies: 7 cherry, 10 blue raspberry, 8 green apple. Now, this little P symbol means probability. So if you guys, I guess I should start with, if you haven't, make sure you open up your practice test from Cami or however you decided to do it. I don't know if you printed it out or what. But if you have that little P symbol in front of something, it's specifically asking for the probability of getting a green apple. So now probability team needs 2 numbers. The top number is how many green apple. The bottom number is going to be how many total candies. So there were 8 green apple. And then total candies, 15, 25. So this would be your answer as a fraction. If you would like to write it as a percent, because I think up here, practice putting it, said to try to put them all as percents. If on the calculator, if you do 8 divided by 25, you're going to get 0.32. So then that's going to be 32%. Which Bella is here, by the way? It just says Bella. This is partially why cameras would be nice. But since nobody wants to put on their camera, I kind of need to know who's in the class to take attendance. So which Bella is here? Okay. Oh. Thank you. I would, if you, I don't know how you're supposed to do it, but I would make sure that your names that appear in Zoom have your first and last name. I'm assuming if you're doing it on your phone or something, it's probably your personal Zoom account, but whatever. You'll probably be getting that all day long, possibly. So, okay, probability of cherry or green apple. Well, that means the 2 numbers we need. The top number is going to be the number of cherries or green apple. The bottom number is number of candies. So cherry or green apple means we're going to add them together. So we've got 7 cherry plus 8 green apple. And the bottom is 25 candies. So we've got 15 25ths, which if you want to write it as a fraction would be 3/5. But we are trying to practice these as percents. So on your calculator, 3 divided by 5 would be 0.6. And then as a percent, you move it over 2. So that would be 60%. Now, I'm going to guess in Cami, do most of you just like use your keyboard to type things on there? Well, everybody wants to use chat. Nobody actually talks. All right. I need to figure out how to have this up without it being in the way. Okay, thanks, Elena. So since this is something that you're probably going to want to use on the test, like taking these notes today, I would guess typing it in on the keyboard is probably kind of rough, or, doing all the numbers probably doesn't work that well. If you guys would like, I mean, you could certainly just write this on actual paper and then, number it on the paper. And then that way you can kind of staple it with your practice test to see how they go together. I mean, if you're good at just like typing it on a keyboard, go for it. But I know a lot of that doesn't always work well. I need to be able to get the messages out of the way here, I guess. Okay. Probability that it is not cherry. Well, oops. Let's go with red. Okay, probability not cherry means I need to figure out how many are not cherry compared to the number of candies. And then I am trying to record this. So if for some reason you trying to take notes is ridiculously slow, I'll try to post the recording so that you can, do it slow or whatever. Not cherry. Well, not cherry would mean everything that is not cherry. So there would be 10 blue raspberry and 8 green apple that aren't cherry. And there are 25 candies. So we've got 18 out of 25. I don't think that reduces. So on my calculator, 18 divided by 25, that'll give me 0.72. 36 and 36, I think, is 72. So it'd probably be 0.72. I move it over twice, and that would be 72%. If you guys run into a question, and obviously everybody currently seems to like avoid the actual talking and actual video like the plague for some reason, you could put it in the chat. It does work a lot easier for me for you to just like ask a question out loud, because then I don't have to open up the chat, but whatever. Ask questions away however you want. Okay, deck of cards.
Is this what the actual test is going to be like?
Correct. I went and took the actual test, and then I made you guys some sample questions that were modeled like it. So obviously it's not going to be the exact same one with candies and cards, but the setup of the test is going to be just like this. So standard deck of cards. I thought this one might be the hardest question for you guys, just because a lot of you may not be familiar with using a lot of cards. So I tried to write as much information as I could, and hopefully it didn't get confusing. But basically cards, there's 13 different cards, and then there's 4 of each type of card. And the 4 things are hearts, diamonds, spades, and clubs. 2 of them are red, 2 of them are black. So they have it separated in a bunch of ways. First thing, sample space. This means just how many things are possible if you draw a card, right? So the sample space is the number of cards. There's 52. You were directly told how many there were. Okay, so that's the sample space. And the reason that's listed first is because when we're doing all these probabilities, it's going to be over 52, because we're going to do probabilities with specific topics out of number of cards. So it's good to know this first. Okay, probability that when you draw a card, you get a jack or a queen or a king. Those are actually called face cards, but I didn't want to write face card on there because I wasn't sure if you'd know what that meant. So probability jack, queen, king. Well, it says there are 4 of each type of card. And so that means there's going to be 4 jacks, 4 queens, 4 kings. So the number of face cards divided by the number of cards. The face cards, there are 4 jacks, 4 queens, 4 kings. There are 52 cards. So what do we have? We have 12 out of 52. Oh, what would have been really smart for me to do is have a calculator here at home. If I want to make this into percent, I'm going to divide them. I got my phone, that works. I'll be like you guys. Just use my phone for everything. 12 divided by 52 is 0.2307. Now, we were going to round to the nearest percent, like whole number percent. So when I move this over 2 spots, it's going to be 23.07%. And that 0 means that I'm just going to keep it as 23%. Okay. Next one.
Do we have
Oh,
do we
go
have
ahead.
to write everything as percent?
I think it'd be good to practice that, especially on the test, just because that's how virtually everybody uses probabilities. Like whenever you're watching TV, any kind of stats they give you is always percents. So it's probably good to practice that. That's why on this this practice test, I wanted to make sure to show you exactly what to do for percents. Okay, probability red cards means we have to write how many red cards there are divided by how many cards there are. Well, red cards. Okay, so there are 4 types of each card. 2 of them are red, 2 of them are black. Now, if we wanted to add up all of these, we could, because there would be 2 of every kind of 2 red of every kind of card. And if we want, sure. There would be 13 2s. So there are 26 red cards in a deck of cards. Half of them are red. And we probably could have figured that out because they're red and black colors. Well, so that means half the cards are red. But up here, like when I wrote all these 2s, you can just add them up if you like, if it doesn't click that you know that there's half. On the calculator, if you divide this, you should get exactly 0.5. So 50%. Probability is not an even number. Okay, so I need to count up how many cards are not even. And divide by how many cards. Okay, not even. Ace, not even. So there's 4 of those. 2 is even. 3 is not even. 4 of those. 4 is even. 5 is not. 4 of those. 7, 9. So there's more. They're not even. 10 is even. Jack, queen, and king aren't even because they're not even numbers. Same as an ace. So we've got 4, 4, 4. How many 4s do we have? 1, 2, 3, 4, 5, 6, 7, 8. 8 4s. That means there's 32 out of 52. 32 divided by 52. According to my professional calculator here, is 0.6153. 0.6153. If I move this over 2 spots, that's going to be 61.53%. This 5 means I'm going to round up. So this would be 62%. And again, I kind of figured this would be the hardest section for some if you're not familiar. Oh, sorry. Just saw the chat. It doesn't make a noise for some reason. Okay. Thank you, Bella. Yeah, this was pretty much the life of distance learning is I would get about 30 messages a day from people that, for whatever reason, Zoom doesn't like their internet. Oh, down the okay. I should probably go pretty quick since it's already 8:56. Mr. Mac Shack, clearly that is me. I was not a good free thrower. So I made 12 of my last 81 free throws. What is the experimental probability? Well, experimental means you're going to look at the numbers that you've used. Probability means I'm going to need two numbers. So I'm going to look at the number of made free throws divided by the number of free throws. Because it says, what is the probability I'm going to make my next one? So that's why the top is the makes. Well, I made 12 free throws and I took 81 free throws. Twelve divided by 81. 0.148. 0.148, which means when I move it over two spots, it'll be 14.8%. Oh, shoot.
Can we round it up to 15%?
Yeah, I was just going to say, I forgot we were rounding the whole numbers. So we will erase that and pretend it didn't happen. And that 8 means you round up to 15. Good catch. Okay, find the number of outcomes. Well, this is telling me that we're just looking for the number of ways. So this is counting. We're not doing probabilities. I mean, I don't think any of these down here say probability. Nope. Okay, so these are all counting. Rolling two 10-sided dice. Oy. Well, rolling each dice is independent. So, because each one has nothing to do with each other, this is going to be the fundamental counting principle, which means you multiply the number of choices. So there's 10 choices or possibilities from the first roll, and there are 10 from the second roll. So there would be 100 ways to roll two dice if they were 10-sided. Picking one of each for an outfit when you have 4 shoes, 3 socks, 5 shoes. Oh, there's a lot of clothes. So I see what 5 different things we're trying on that automatically right away that tells me it's not permutations, not combinations, because there's 5 different things. And if it's not permutations or combinations, it has to be fundamental counting principle. So I'm going to just multiply my number of choices. Shoes, socks, shorts, shirts, hats. 1260, 480 times 2, 960, maybe.
That's what I got.
What?
That's what I got.
Oh, perfect. All right. I know. I suppose you guys had the answer key already anyway. So you should know all these correct answers. I'm just going to go over why we get them that way. I have requests from 13 students to play a certain song, but I only have time to play 3 songs in a certain order. Well, the word order there is what is going to help us out a lot, because the word order means it's going to be a permutation. And I've got 13 different songs requested, but I can only play 3. Whatever that answer is what we would have. I have a bowl of leftover Halloween candy that my children classify as gross. Normally I do, but since I was sick this year, I couldn't do Halloween, so I didn't have leftover candy. There are 29 different types of candy in the bowl, and I say a lucky student can pick 4. How many ways can that student choose? Okay, well, the how many tells us for sure we are combinations or permutations. The order they choose the candy won't matter, because they're still just picking 4 types of candy. So since there is no order, this is going to be a combination. So I would say there are 29 types of candy. That student is picking 4. And whatever that answer is would be the answer. Now, if I remember correctly, the real test has like 2 or 3 more types of questions, but I basically was rounding out of space and I wanted to fit this all on one page for you guys, even though it didn't end up being printed. So I cut down the number of combinations, permutations, and counting principle questions. So the real test has a couple more of these. This is approximately how many probability questions to be on the test. Oh yeah, perfect. I don't know. So you guys can certainly come in tomorrow, a couple minutes before class if you want to ask a question real quick. But otherwise, this is basically what the test is going to look like. All right. See you guys later. Stop. How do I stop recording? I don't remember. More. No. Stop recording.